Hello and welcome. So this tutorial video is going to be about variables. It will mainly focus on Python, but it can also apply to some other languages. So first of all, what is a variable? A variable is a named location in memory which is used to store or hold a value, and the value that is stored can be changed or updated. And when we say it is a named location in memory, that means main memory, which is RAM. So we have a location in memory, we've given it a name, and we're going to store some kind of information or data inside that. And then every time we want to retrieve the data, we can just use the name that we gave that location. So in Python there are 3 rules when you create a variable. I'm going to open up idle so that we can show you these. So I'm going to go new file as always, and the first rule is that our variable cannot have any spaces. So an example of this, if we put first space name equals Bobby, and we run this, and I'll have to save it, so okay, change to tutorials, variables, you will notice that we get a error which is saying invalid syntax. Syntax means we broke the rules of the language, so we've broken the rules of the Python programming language. We are not allowed a space. If I get rid of the space and run it again, it runs without issue. It doesn't actually do anything yet, but it does in fact run. So the second rule is that you can't start with a number. So at the beginning, you can't start with a number. If I type a random number, let's put 2, and try to run this, we get the same error, invalid syntax. And this time it's very helpfully highlighted the location of the error in red. So if I get rid of the 2 again, it will work. The final rule, the final official rule that will cause an error, is that you can't have any punctuation except for an underscore. So if I put, for instance, a question mark at the end, it will give invalid syntax. However, if I use an underscore anywhere in the variable, it will still work. So in order to combat this, instead of putting spaces, we tend to either put a underscore if we want to put a space, so first underscore name, or we can capitalize the first letter of each word that comes after the first word, and that is called camel case. So it's meant to represent the humps of a camel. Now, an unofficial rule is that the first letter of the variable should also be lowercase. So the first word should be lowercase, and then the first letter of the second word is uppercase, and the rest is again lowercase. And while that won't actually give you an error, I can prove this, it won't give you an error, it is actually considered bad practice to capitalize the first letter of variables. You should reserve that for class names, file names, things like that. So now we have our methods of creating a variable. So we have variable, so first name is equals to, and we've given it the information Bobby. And this is a string. So there are 4 data types used frequently in Python. Some languages separate these out and use a couple of extra ones, but in Python there's 4 that we really need to worry about, plus lists and things like that. So the first is a string, and a string can be any text, numbers, punctuation, including spaces, anything that you can type on the keyboard, as long as it is inside these quotation marks. So if I get rid of the quotation marks, we will again have an error. And this time it says name Bobby is not defined. That is saying it thinks we're trying to set it to a variable, as variables don't have the quotation marks, and it thinks we're trying to set first name to the value of a variable Bobby, but the variable Bobby doesn't exist. So it does indeed need to be a string, and that is shown by the quotation marks. So important to note, inside the quotation marks, a string, we can put spaces. So I can put Bobby twice and it will still work. So the second data type we want to consider, let's keep that. So the second data type we want to consider is an integer. So an integer is any whole number, as you should hopefully know from maths. So if I create a variable called age, so the variable age is going to be set to, and we're going to say 15. So integers, whole numbers, do not need to be inside quotation marks, as you will see. However, if you try to put a space between any of the numbers, you will notice that you get an error. So very important when you're creating integers or float, which we'll come to in a moment, the number can't have any spaces in. It doesn't make sense to put 1 space 5 for 15 anyway, but if it's a normal number, then we don't need the quotation marks. The next main data type we want to consider is a float, and a float is any decimal number. So as long as it has a decimal place, it can be a whole number, so it can be 1.0 or 2.3. As long as it has a decimal, it will be a float. So if I create a variable for height, and I could set it to 168.5, and again, this doesn't need quotation marks as it is in a float. If I run this, you can see that it works. And the last data type that we want to consider, although when you're first starting out you won't really use it that often, but it is extremely useful, is a boolean. So boolean can either be true or false. You could say end task equals true, and you will notice that it has a capital T and the boolean has turned orange. You will also note that the string up here is green. So if I run this, it will now continue to work. So we have a string inside quotation marks, an integer, a float, and a boolean. It's important to note that if you add quotation marks to the number 15, the age, it will still work. So if I type that in and press run, it still functions, but that will now consider itself a string. And this is important. So to show this, I'm going to create two numbers. I'm just going to call them number 1 and number 2. And we'll go 5 and 6. If I say answer equals number 1 plus number 2, and then we want to print out answer, if these are both integers, 5 and 6, then answer is 5 plus 6, which should print 11, and we will see it displays 11. However, if I add quotation marks to both of these, so we have 5 as a string plus 6 as a string, this will actually add them, but the second function of the addition sign in most programming languages is called concatenation, and that effectively means add two strings side by side, and we can see this happen. So if I run this, it will say 56, and all it's done is it's put the 6 to the right of the 5. So 5 plus 6 as two strings is 56, not 11. And that is quite important. I think it tricks quite a few novice or beginners into programming. Most people like to write the quotation marks just to see this turn green, when in fact you don't want to do that if you're trying to do any maths. So to prove that again. So one final demonstration is that if I create two different numbers, we'll call one num as float, we'll call this 5.0, we'll go num as int equals 5. If we then want to check that this is in fact stored as a float and this is an integer, I can type print type, which tells you the data type, num as float, and then do the same again for num as int, and you can see the first one says that it is a float, so 5.0 is a float and 5 is an integer. And while I will go into if statements later on, so don't worry if you don't understand the if statement I'm about to do, but if I create an if statement which says if num as float is equal to num as int, I'm going to print yes, otherwise or else I'm going to print no. You will see these actually say that they are the same thing. So this says that num as float and num as int, so 5.0 and 5 are exactly the same, they are equal to each other. If however I do type num as float and type num as int, get rid of that, this will say that they are not the same. So the type, the data type of the float is not the same as the integer. And again, this can cause a couple of problems later on in accuracy. If you're trying to add integers and floats, sometimes things don't go perfectly to plan. If you want to add two things together, it's better to convert the integer to a float and then you can add it together. Which brings me to the final point, is that you can cast or convert between data types. So if I say number 1 equals str number 1 and then print type number 1, this should say it is a string. So let's explain this. So we're taking our variable number 1, we're converting it or casting it to a string, and then we are storing the string version of number 1, replacing the old int type. So it replaces the int num1 with the string number 1, and it now says that it is a string. If I change it to float and run this again, then the class now says that this is a float. So as long as this is a number, you can convert between string, float, and integer. However, do not get this confused. If you try to convert first name into a float, then you will get an error. And this will say could not convert string to float. And it's saying we're trying to convert Bobby and it's just not possible. So you can't convert text, that is letters, symbols, spaces, into a float or an integer. But you can, as long as it is a number and only a number, even if this is 5.0 and you want to turn it into an int and you run it, it will convert it into an integer. Now, of course, if we have 5.2, if you convert number into an int and then you want to do the same as this, let's copy it in fact. So we do the same as before, but we've changed number 5.2 into an int, and then we've added 5.2 plus 6. Well, it's not going to do that. If we run this, you'll see it comes up with 11 instead of 11.2. So 11.2 was this one. 5.2 plus 6 is 11.2. This one, however, we've changed the 5.2 into an integer, and it's cut off that decimal place. So it's just left it as 5 plus 6, which is simply 11. So hopefully this has acted as a short demonstration into variables. We've covered how to actually create a variable using the equal sign, what strings are, integers, floats, and booleans, as well as some of the inner workings of how these different data types interact with each other and how we can actually use them in our programs. Thank you for listening.